Good morning, everyone. Welcome to the class. Today, we are going to continue to explain the force. We haven't finished yet. And just let me remind something from last lesson. And we were proceeding the mass and weight in the last lesson. And we talk about the differences and relation between them, right? Okay, let me give the short information. The mass is the amount of matter in any object, okay, and mass never changes from one planet to another planet, okay, because mass doesn't depend on gravity, okay guys, mass never changes in universe, but but the weight can change. Why? Because weight of any object depends on the gravity with the mass, okay, depends on the gravity. And also guys, what was the unit of mass? Unit of mass is kilogram or gram. Unit of weight is just Newton. Why? Because weight is a kind of force guys. Okay. And also there was a formula, the weight is equal to mass time gravity, and the value of gravity is constant and it's equal to the 10 Newton over kg. Okay. And I give you some homeworks in the last lesson. Let me solve those questions. Some of you has sent them homeworks, but most of you haven't sent yet. I'm still waiting, guys. Okay. Okay. Question D. This is okay. Okay, guys. As you know, the weight is equal to mass time gravity, right? Okay, what is the mass of the bowling ball is 7.2 times, kg, right, times 10 Newton over kilogram. Kilogram simplified, and when you multiply 7.2 by 10 Newton is gonna be 72 Newton. Okay, 72 Newton, and it means actually that's the weight of the bowling ball on the Earth. Okay, how about on the Moon? Let me write here on Earth. Okay, W actually weight of the bowling ball on the Moon, and as you know, guys, the gravitational field strength on the Moon is 6 times less than the gravitational force on the Earth, right? As you remember, okay, 72 Newton times 1 over 6, the result is going to be 12 Newton. Okay, when this bowling ball goes to the moon, what is gonna be its weight? Its weight is gonna be 12 Newton, but on the Earth is 72 Newton. Okay, this question, let me write again. The weight is equal to mass time gravity. Okay, G. And what is the mass? Mass is 12 kg times 10 Newton over kg. Kg simplified, and 120 Newton is the travel bag's weight. Okay, on the Earth. How about on the moon? Let me write here Earth, and weight on the moon 120 Newton times 1 over 6. The result is gonna be and 20 Newton, right? On the moon of the travel back. Okay, this one, school chair, weight, mass, time, gravity. What is the mass of it? 3.6 kg times 10 Newton over kg. Kg simplified. The result is going to be 36 Newton on the Earth, and on the moon 36 Newton time 1 over 6, the result is going to be 6 Newton. Okay, as you see, the same question are very simple, and I think you have I think you understood very well. Okay. Okay, the next title, the force diagram. Okay guys, in the physics we are symbolizing the force by arrow. Okay, the arrow like that. The length of the arrow depends on the force. If the force is greater than any other force, we are showing that force with long arrow. Okay, if the force is low, we are showing that force with the short arrow. Okay, and this direction also this shows the right side acting of the force in which direction. Okay, for example, if you show the arrow like that, it means the force acting on the right direction. If you show the arrow like that, it means that force is acting on the left direction. And also we can show up and down like this. Okay, let me clean them. Okay guys, okay, you can read this part. Okay, I don't want to read now, and just let me summarize it. The weight, as you know, the weight depends on the gravity, and the direction of weight, okay, is always through downward, guys, right? The direction of weight, the weight is a kind of force, right? The direction of weight is all the time through downward. Why? Because earth pulls everything on the surface through itself. Okay, that's why the direction of weight through is downwards. Okay, okay guys, when you sit a chair, when you put a book on the table, okay, uh, actually our weight is always acting downward, right? Like this guy, for example. When you sit the chair like that, your weight, the is symbolized by C, is our weight, okay? It's our weight. It's always acting through downward. But also at the same time, the chair reacts to ourselves. Okay, how? When you sit on the chair, for example, your weight is 10 kg, 10 Newton, oh, sorry, 100 Newton, okay, 100 Newton. And also chair acts, react the same amount of force through upwards, guys, okay, 100 Newton. It's action and reaction. Think like action and reaction. When you sit the chair, when you apply the 100 Newton by your weight, and also chair applies a force through upwards, same force. Okay, same force. For example, when you put a book here, okay, for example, it's 10 Newton. Its weight is through downward, right? But also at the same time, the table applies the same force through upward, 10 Newton. For example, on the rock on the ground, you see here, the weight of the rock applies a force through downward, okay, weight of the rock. And also the ground applies a force through upward at the same time and same amount of force through upward, guys. Okay, for example, if you say 100 and also it's 100. Yeah, you can think like that. For example, think a wall, okay, it's a wall and there is a boy here and apply in trying to push the wall, right? Maybe 500 Newton. Okay. At the same time, wall also reacts to that force and it also apply 500 Newton through the boy, guys. Okay, this is called reaction. This is action, guys. Okay, and also we can call applied force. Okay, I hope you understand me. think like action and reaction. When you sit anywhere or when you push anything, they also apply a force through yourself, through opposite direction. Okay. When you sit a chair, and also chair applies a force opposite the opposite direction of your weight, guys. Okay. You should think like that. Okay, friction. Friction is a force that acts in opposite direction or to the applied force. The friction is created by contact between the object and solid surface. Yes, guys. When you move, when you run, or also when you drive anything on the earth, there's a force which acts opposite direction of your movements. Okay, that force is called friction. As you seen on the picture, when you kick the ball moves on this direction, right? But after a while, after some minutes or some seconds, you are gonna see the ball will stop. Why? Because guys, the ground applies a friction force in the opposite direction. Okay, this friction stops the ball in some seconds. Okay, that force is called friction. For example, when you drive the trolley like that, okay, you apply a force in this direction, but the friction on the ground also applies on the opposite direction. Okay, that friction, that force is the cause of stopping the materials, subjects, objects. Okay, when you drive a bus, the movement of the bus is on this way, but the friction always in opposite side and is on this way. Okay, what happens if the friction doesn't exist in the life? You know what happens? We can't stop anything on the earth, guys. We can't stop anything on the earth. The friction, that's why, is really important. Okay, for example, if the friction doesn't exist on the earth, when you kick the ball will never stop, guys. Nothing can stop the ball. Okay, if you don't put anything on in front of it, nothing stop the ball. For example, when you drive a car, if the friction doesn't exist, nothing can stop the car or any minibus. Okay, I hope you understand what I'm saying. That is really important. The friction is really important. Even you can't stop, you can't stand on the foot, right? On the what in the erection, what in the erect position. Why? Because the ground will be very slippery, guys. Okay, if the friction doesn't exist. I hope you understand me. The friction is really important in the life. Okay, guys. Okay. Let me answer these questions. Look at these pictures which show, and also the page, that page is belongs to the workbook, page 52. You can open it. Look at these pictures which show forces in action. Draw an arrow on each picture to show the direction of the named force. Write next to the arrow whether the force is a push or a pull. Okay, guys. Okay, you see the feather here, right? The force of gravity acting on the feather. Okay, it's a push or pull. It's a pull, right, guys? Because the gravity pulls the leaf through itself, through the grounds. Okay, that's why this is pull. How about this one, guys? The force the child is applying to the go-kart. Okay, the force is acting on this side, right? And also it's the boy, the child is pulling the go-kart. Okay, guys. How about this one? The force the wind is applying to the sail. Yes, when the wind hits to the sail like that, okay, what happens? The wind push to the sail on the same direction, right? And also sail and wind, okay, wind and sail moves on the same direction. That's why we are saying that is push, guys. Okay, that is push. Okay, the magnetic force is acting on the iron filings. Yes, when the iron here, the magnets also are pulling, attracting the iron filings through itself, and also it's called pulling, guys. Okay. Which do you think is the strongest force in the pictures? Explain your thinking. Yes, guys, this is the strongest force. Why? Because the mass of the sail is greater than any of objects here, right? Any of objects here. The mass of the sail is greater than any objects here. That's why the winds must apply more force than any other force on the picture. Okay, that's why the answer is C. And also I explained, you can take notes, guys. Okay, guys, thank you for listening to me. That this page is your homework, and please don't forget to submit on EduPage, or you can send on WhatsApp. Okay, and you can do your best, guys. Thank you for listening to me, and see you. Have a good day.